In the name of God, my name is Mohammad Noori. Now today we want to talk about gRPC systems. gRPC is one of the API writing methods architecture, and now we can use gRPC in microservice and other systems. So let's go to the presentation. This is the table of contents. At first, we want to talk about what is the RPC, and after that, what is gRPC architecture, protocol buffers, how does a protocol buffer work, protocol buffers architecture, gRPC supported languages, and at last, we jump into code and see an example. So, what is RPC? RPC is the abbreviation of Remote Procedure Call. It has been established since 1970. It means that if we have two applications A and B, we can recall, or it's better to say call a function or method from A inside B, or vice versa. It can help us to design distributed systems, and we can achieve best performance in microservice by gRPC and RPC systems. So, what is gRPC? gRPC is actually a fast and powerful RPC framework developed by Google and several other companies. The first G is in the name. gRPC is a short abbreviation for Google. It means that Google Remote Procedure Call. That gRPC is an independent language architecture. It means that you can connect two applications to each other, that one of them is developed by C++ or Ruby or Python, and each other is developed by, for example, Go, Node.js, or some programming languages. So, now let's talk about gRPC architecture. In gRPC, a client application can directly call a method on a server application on a different machine as if it were a local object, making it easier for you to create distributed applications and services. So, if you have a microservice architecture, it means that you have many applications that connect to each other with some APIs, and any of them written in different programming languages. The best choice for connecting these applications to each other is using gRPC architecture because of language independencies and loose data consumption and safety and more speed. Now you can see key features of gRPC. At first, binary communication. The second is communication based on protocol. The third one is safe because of default use of HTTP2. And after that, streaming in server and client. And at last, useful for microservice architectures. So, now let's talk about protocol buffers. By default, gRPC uses protocol buffers. Google's major open source mechanism for serializing structured data, although it can be used with other data formats such as JSON. The data in gRPC architecture is stored in protocol buffers in binary format because of less traffic consumption and increasing safety and speed. How does a protocol buffer work? The first step when working with protocol buffers is to define the structure for the data you want to serialize in a protofile. Protofile is an ordinary file, text file with a .proto extension that you should define your structure for communicating messages and data that you want to communicate between applications. Now let's see an architecture of protocol buffer. You can define gRPC services in ordinary protofiles with gRPC method parameters and return type specified as protocol buffer message. You can see in the image that at first we define a service by the keyword service and the name that you choose for your service. In this example, we choose a greeter name, and keyword RPC define your name, and after that input data. So it's better to say hello request is parameter of say hello, and the return type that in this example it is hello reply. After that, you should define the structure for input and output values for this service. At first, you should type a keyword message, and after that, write the name of the client input, hello request, and after that, you should define the data type of this input. In this example, we have a string example. So you should write a string keyword and define a name for that, and equals to 1. This number is I think it is indexed for the different part of client input. And after that, you should define the client output structure. Like the last example, you should type keyword message, and after that, hello reply. Define the data type for this client output, and equals to an index that you choose for that. Now you can see gRPC supported languages. The most important languages that gRPC supports is C#, C++, Dart, Java, Kotlin for Android developers, Python, Node.js, Objective-C for iOS or Mac OS developers, PHP, and Ruby programming. Now let's jump to the code and see a small example. At first, you should create your .proto file. In this example, like the example that you see in the slides, you should define the structure for communicating a message between client and server. At first, represent the name of the service and the function name greet. So our service name is greeter and our function name is greet, which can be called the greet function takes in the input of type client input and returns the output of type server output. Now let us look at these types. In the above block, we have defined the client input, which contains two attributes, greeting and the name, both of them being strings. The client is supposed to send the object of type client output to the server. After that, you should run a command to your terminal that create the basis for using gRPC in your systems. Before that, you should, for Python, use pip install gRPC IO and pip install gRPC tools for installing the packages that's required for using gRPC. And after that, you should create a server and a client. For a server, you should import gRPC at first, gRPC PB2 and greeting PB2 gRPC that created by this command into your terminal. So after that, you create a class greeter that inherits from greeting PB2 gRPC dot greeting server, and this section you should define your function name that define in the proto file greet. Write something to print that you can see the server worked correctly, and typing some message, and at least return the object that you want to communicate between server and client. After that, you define your server function, def server, and we have a variable named server that equals to grpc.server futures.thread pool executor max workers 2. This is a configuration for server side of your gRPC application. After that, you use the basic files that you lastly created by the commands in your terminal, and write some configuration and print something to show you that server is working correctly. After that, you setting up your client. At first, import gRPC, import greeting PB2 gRPC, and define a function with name run. Use the keyword with gRPC dot insecure channel localhost. This is the address or the URL that gRPC runs in it, and define a name for this section of code. Here we have a stub variable. A stub points to a client in which programming languages. No, just a particular language. In every language that you want to implement gRPC, you should have a stub that this word is point to client. You define a stub, and after that you define response, and at last you print some message that show you that your client is worked correctly. And after that you recall your run function, and in the terminal you can see the gRPC starting. This is for server running, and after the running client you can see greeter client received following from server you John. This is the message that you define in your client Python file. Thank you for your attention.